Hi class, for this assignment, I'm going to show you how to actually graph some of these using Desmos. So we're going to be using technology. So we're going to redo the previous assignment, but now using technology. So the first one is X. So technically, all I need you to do, and let me redo this one again so that you see it. So once you go to Desmos, you can just input the y is equal to x portion, and then you can see there the actual function. Let me give you the coordinate points that we punched in: -1, 1 as your -1, -1. That was our first coordinate point. Then our second coordinate point was 0, 0. Our next coordinate point was technically 1, 1. Now you don't need to label the points. I'm just interested in you guys actually running Desmos and being able to graph each one of those graphs. So this is what you're submitting for the first one. So you're just submitting all the pictures using Desmos. So you can just take a picture, and I do want to see that you're actually graphing that, and then, well, what it looks on the screen. So you can take a picture of that. Let's take a look at the second one. And our second graph had to do with an x squared or a parabola. So let me show you this one on Desmos. We're going to go back to Desmos and technically change that to an x squared. Let me remove the coordinate points. They're not needed. You can actually see here 0, 0, which is your reference. And if you review your notes, you should have -1, 1 as one of the coordinate points. And the next one, 1, 1. So these are the ones that we actually found. Earlier by doing algebra. Let me put them as blue so that they look better. But you don't need to actually label them or show those in the screen. If you did wanted to see the coordinate points, you can see them there. I do recommend that you try what I'm doing, because some of the graphs you may not remember what they look like, especially if you took algebra a long time ago. So take a picture of the screen. That would be your second one. Let's take a look at another one that we did. And let me do for you guys the, let me do D. You can do, well, technically C. And graph D, it's an absolute value. So let me remove all of it. So y is equal to ABS, and technically it should be X. And there's your absolute value. Graph the coordinate points, -1, 1. It's there. Technically the origin, and then also 1, 1. Those are the ones that we used when we graphed it. You can actually see here that, well, you're getting a better sketch. And then take a picture of this one. I do recommend that you type in the coordinate points, just because it'll be easier for you guys to review some of the graphs if it's been a long time. So let me actually jump to the last one, and this is the log one. So in the log one, we experienced something that you didn't do for the previous ones, and that is it wasn't allowing us to evaluate 0 and any negative values. So you would just plug it in as y is equal to a log, and that's a log of x. Let me go to the origin, and you have it here. So we try to plug in x is equal to -1, and I'm going to just make this a dotted line because it's not part of your graph. You can actually see this particular sketch or your log function. It's not on the actual, it's not on the negatives. It basically just stays in here, and then it follows that actual line. And then we also tried as the coordinate points of 1 comma log of 1, which is technically 0. And then we tried, I think it was 2 comma log of 2, and then 3 comma log of 3. Whoops, there you go. And those were the 3 coordinate points that we used. You can actually see here that as I zoom in, and I'm referring to this portion here, as I zoom in, it looks from afar like it's touching 0, but it's actually not going to touch 0. Look at the values of 2 on the y's. As I zoom in, there's always a space. So you technically have an asymptote of that one. You don't need to include the -1. That was just to show you guys why you couldn't actually evaluate the graph at that point.